Have you ever wondered just how vast the universe is? Imagine standing at one end of a beach, looking out at the vast expanse of the ocean stretching as far as your eyes can see. Now multiply that feeling of infinite space by a number so large it's almost impossible to comprehend. That's the universe. Our universe, this grand cosmic theater, is estimated to be about 93 billion light years in diameter. Let's pause for a moment and let that sink in. 93 billion light years. But what exactly is a light year? A light year isn't a measure of time, although it might sound like it. No, a light year is in fact a measure of distance. It's how far light traveling at a speed of approximately 186,000 miles per second can get in a single year. To put that into perspective, if you were to travel at the speed of light, you could circle the Earth 7.5 times in just 1 second. Now consider this, light from the sun takes about 8 minutes and 20 seconds to reach us here on Earth. That's a mere 93 million miles away. When we talk about distances in the universe, we're not talking millions or billions of miles, we're talking light years. So a single light year is about 6 trillion miles. Multiply that by 93 billion, and you start to get a sense of just how colossal the universe is. But remember, these are only estimates. As our understanding of the cosmos deepens and our technology advances, these numbers may change. After all, the universe is not just a static backdrop. It's a dynamic, ever-evolving entity. So, when we say the universe is 93 billion light years across, we're talking about distances almost too vast for the human mind to comprehend. Did you know there are more galaxies in the universe than grains of sand on Earth? That's a staggering comparison, isn't it? The universe as we know it is vast, teeming with galaxies far beyond our comprehension. Now, let's dive into some numbers to grasp the magnitude of this statement. The latest estimates suggest that the universe is home to around 2 trillion galaxies. That's right, 2 trillion. It's an almost inconceivable number, isn't it? Try to imagine 2 trillion of anything, let alone galaxies, each brimming with billions of stars. And you might begin to grasp the vastness of our universe. Now, let's juxtapose this with the number of grains of sand on Earth. It's estimated that there are roughly 7.5 quintillion grains of sand on Earth. To put it into perspective, if every grain of sand represented a single second, it would take over 200 billion years to count them all. And yet, this number pales in comparison to the number of galaxies. So what does this mean? Well, for every grain of sand on every beach, in every desert, and buried beneath every ocean on Earth, there are over 100 galaxies out there in the cosmos. Each of those galaxies is a cosmic city, teeming with stars, planets, black holes, and potentially life. It's a mind-boggling comparison, but one that perfectly illustrates the enormity of the universe. It's a reminder of our small, almost insignificant place within it, and yet also speaks to our incredible ability to comprehend and explore the cosmos, despite our size. It's a testament to human curiosity and our relentless pursuit of knowledge. We may be small compared to the universe, but our desire to understand it is as vast as the cosmos itself. That's right. For every grain of sand on Earth, there are over 100 galaxies out there in the universe. Can you fathom how old the universe is? It's a question that has piqued the curiosity of scientists, philosophers, and thinkers alike for centuries. As of now, the best estimate we have places the age of the universe at a staggering 13.8 billion years. But how did we arrive at such a colossal figure? Let's delve into the world of cosmic microwave background radiation, or CMB. Imagine the universe as a grand cosmic oven. When it was just a baby, about 380,000 years old, it was filled with hot, dense plasma. As the universe expanded and cooled down, protons and electrons combined to form neutral hydrogen atoms, which allowed photons to travel freely. This is what we refer to as the moment of last scattering, the echo of the Big Bang itself. These photons, once a sizzling 3,000 degrees, have cooled down over the eons due to the expansion of the universe and are now just about 2.7 degrees above absolute zero. These are the oldest photons we can observe, a snapshot of the universe when it was very young. This is the cosmic microwave background radiation. By studying the CMB, cosmologists can estimate the age of the universe. They analyze the patterns of the tiny temperature fluctuations in the CMB and compare them with the predictions from the Big Bang theory. The results have been astonishingly consistent, leading scientists to conclude that the universe is approximately 13.8 billion years old. That's a number so large it's almost impossible to comprehend, and to put it into perspective, if the entire history of the universe were condensed into a single year, each second would represent about 438 years, and our Earth, it wouldn't even come into existence until late in December. That's nearly 3 times the age of Earth, making the universe a truly ancient entity. We are small transient creatures in a universe that has been around for an unimaginably long time. How fascinating is that? What's the fastest thing in the universe? You might be tempted to say a shooting star or even a rocket, but the answer is far more extraordinary. It's light. Light zips along at a mind-boggling speed, the maximum speed at which all energy, matter, and information in the universe can travel. This cosmic speed limit, if you will, is a staggering 670 million miles per hour. Now let's put this into perspective. If you could travel at the speed of light, you could circle the Earth 7.5 times in just 1 second. That's faster than a blink of an eye. Now imagine trying to race light. You'd be left in the dust before you could even get your engine revving. But what does this speed limit mean for us, particularly in terms of space travel and communication? Well, the implications are profound and a bit humbling. Even at the speed of light, a trip to the nearest star, Proxima Centauri, would take over 4 years. That's longer than most people spend in college. And sending a message, that too would take over 4 years to get there and another 4 to get a response back. In our solar system, the delays are more manageable but still significant. A message to Mars, for instance, can take anywhere from 3 to 22 minutes one way, depending on our respective positions in our orbits. And that's at the speed of light. In other words, the universe is not just vast, it's also incredibly slow by our standards. This speed limit set by light is one of the many factors that make interstellar travel and communication so challenging. So, while we may dream of traveling to distant galaxies, the speed of light sets a hard limit on just how quickly we could get there. It's a reminder that, in the grand scheme of things, we're not just small, we're also incredibly slow. Did you know that the universe is getting bigger every second? Now, that's not just a throwaway statement. It's a proven fact backed by solid scientific evidence. The concept of a constantly expanding universe is something that's been accepted by the scientific community for quite some time now. It was first proposed by the Belgian physicist Georges Lemaitre in the 1920s and later supported by Edwin Hubble's observations. Hubble noticed that galaxies appeared to be moving away from us in every direction. The further away the galaxy, the faster it seemed to be receding. This phenomenon, known as the Hubble's law, was a key piece of evidence supporting the idea of an expanding universe. Now, you might be asking, how exactly do scientists measure this expansion? Well, they use a unit called a redshift. When scientists observe a galaxy, they look at the light it emits. If this light is shifted towards the red end of the spectrum, it indicates that the galaxy is moving away from us. The greater the redshift, the faster the galaxy is receding. And what does this mean for the future of our universe? Well, if the universe continues to expand at an accelerated rate, we could be headed towards what scientists call a big freeze. In this scenario, galaxies would move so far apart that they would no longer be able to interact with each other. Stars would burn out, leaving behind a dark, cold universe. But before you start panicking, remember this. We're talking about an event that won't happen for billions upon billions of years. For now, we can marvel at the beauty and mystery of our ever-expanding universe and continue to explore its many wonders. So, not only is the universe unimaginably vast, but it's also growing larger every single day. What are the biggest mysteries of the universe? A question that leads us directly to the enigmatic concepts of dark matter and dark energy. These unseen and still largely unexplained phenomena make up a staggering 95% of the universe. Yes, you heard that right. The stars, galaxies, and cosmic dust we can observe account for a mere 5% of all there is. Dark matter, the more elusive cousin of the two, is thought to account for approximately 25% of the universe's total mass energy density. So what is it? Well, we're not entirely sure. We can't see it or detect it directly, but we know it's there because of the gravitational effects it has on galaxies and galaxy clusters. Without the influence of dark matter, galaxies would spin apart, unable to hold themselves together. Then there's dark energy, making up around 70% of the universe. It's even more mysterious. This hypothetical form of energy is believed to be the driving force behind the accelerating expansion of the universe. But how does it work? What is it made of? Those are questions that continue to baffle the brightest minds in cosmology. Scientists are using a variety of methods to try and unlock the secrets of dark matter and dark energy. From particle accelerators to deep space telescopes, we're throwing everything we've got at these cosmic conundrums. Yet, despite our best efforts, they remain largely shrouded in mystery. But it's this mystery that makes the study of the universe so fascinating. Each discovery, each revelation brings us one step closer to understanding our place in the cosmos. And in the case of dark matter and dark energy, it's clear we still have a long way to go. So while we may have learned a lot about the universe, there's still much that remains a mystery. And isn't that a thrilling thought? Isn't the universe a fascinating place? It's a realm of cosmic wonders and mysteries that boggle the mind. As we pull together the threads of our exploration, it becomes clear just how truly remarkable our universe is. Let's take a moment to marvel at the universe's vastness. Space, as they say, is big, really big. You just won't believe how vastly, hugely, mind-bogglingly big it is. It's an expanse so large that our human minds struggle to comprehend its size. And within that vast expanse, there are countless galaxies, each one a metropolis of stars. Speaking of galaxies, there's an astronomical number of them. It's estimated there are 2 trillion galaxies in the universe, each teeming with billions of stars. That's a 2 followed by 12 zeros, a number so large it's almost unfathomable. Then there's the age of the universe. It's approximately 13.8 billion years old. Think about that for a moment. The universe has been around for nearly 14 billion years. That's older than the Earth, older than the Sun, older than all of human history. Let's not forget the speed of light, the cosmic speed limit. Light travels at a staggering speed of approximately 186,000 miles per second. That's fast enough to circle the Earth 7.5 times in just a single second. The universe is also ever expanding, growing larger every second. It's like a balloon being blown up with galaxies moving away from each other as space itself expands. And finally, we come to the enigmatic dark matter and dark energy. These invisible, undetectable forces make up a significant portion of the universe. They're the wild cards, the great unknowns. Their existence is inferred, but their nature remains a mystery. The more we learn about the universe, the more we realize just how much there is still to discover. It's a never-ending journey, a ceaseless quest for knowledge in the grand cosmic theater of the universe.